Thales, upon reflecting on geometry that he had learned in Egypt, was the first man to arrive at geometrical truths, which we now call theorems. That is, the statements which can be rigorously proved. The first of these was that if two straight lines intersect, the vertically opposite angles are equal. He proved this in a very simple way. He tied two sticks together with a piece of string and made an impression in the sand. He turned it around, interchanging the angles, and found that the impression fitted perfectly. He therefore said the vertically opposite angles are equal. Not sometimes, but always. He also stated that the base angles of an isosceles triangle are equal. He proved this in a very simple way. He made an isosceles triangle with sticks and made an impression in the sand. He turned it around, interchanging the angles, and found that it fitted the first impression perfectly. Therefore, he concluded that the base angles of an isosceles triangle are equal, not sometimes, but always. The ancient Greeks studied geometry on the beach using sand reckoning techniques like this. The most famous theorem in geometry is Pythagoras' theorem. It is a statement concerning a right-angle triangle. Here I have a right-angle triangle, and we can identify all three sides. This side here is the hypotenuse, which is opposite the right angle, and this side here is the shorter side of the two. That's the short side, the long side, and the hypotenuse. Pythagoras' theorem states that the square based on the hypotenuse is equal to the sum of the squares based on the other two sides. He proved this theorem in a very simple and ingenious way. He took a right-angle triangle and made an impression in the sand like so. And here we see the impression. This is the hypotenuse, this is the short side, and this is the longer of the two sides. He then made series of impressions around this triangle as follows. To the longer side, he attached the shorter side in line with this edge here, and then to this longer side, again, he attached the shorter side with the right angle looking inwards, and again to this longer side, he attached the shorter side, and completing the pattern which resulted in a square. Now, these triangles can now be filled in, which I will do here, and you will see that that will now constitute a square with a little square in the middle, which we will fill in here with this little black square. Now, this results in a square based on the hypotenuse. We have a hypotenuse by hypotenuse, which is the hypotenuse square. And this hypotenuse squared is made up of 4 triangles and 1 small square in the middle. Notice that there is a relationship between the shorter side and the longer side. If we add this length of the small square to the shorter side, we will get the longer side, and if we subtract this shorter square length from the longer side, we will get the shorter side of the triangle. He then rearranged this pattern by shifting this triangle into this position and by shifting this triangle into this position. he then noticed that this is the same area as before, made up of 4 triangles and a little square, but now we have 2 squares. One is based on the shorter side, this is the shorter side, and this side here is made up of the long side minus the little square of the base, which gives you the short side. So this is short by short, and this side here is the short added to the length of that little square, which makes it long, and this is already long. So you see that we have 2 squares, the short squared and the long squared. So the short squared plus the long squared gives you the hypotenuse squared, and that is the essence of Pythagoras' theorem.